Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will continue talking about the compound events and their probabilities. Let's begin with the first example. An urn contains 5 red balls, 3 white balls, and 2 green balls, so it contains 10 balls, and we need to select 3 balls randomly and successively with replacement from the urn. So remember, in this case we are talking about the successive with replacement selection. That's it. So we need to use exponents, and the order is very important. Let's begin with the probability of A. For A, the selected balls are green. So we need to select 3 green balls from this urn. So the selection would be green, green, green over the total number, and the total number in this case is 10, 10, 10. As you notice here, the total does not decrease. Now for the numerator, pay attention. In a successive with replacement selection, we can in fact select 10 green balls even if we just have 2, because after each selection we're going to replace the green ball again to the urn. So the answer would be 125. Now for P of B, the selected balls have 3 different colors. In this case, we have red, white, green, and don't forget the order. And the order in this case is 3 factorial. Now for red, we just put 5. For white, we put 3. And for green, we put 2. And this is the order. Now for P of C, at most one white ball is selected. Let's see the meaning of at most one. This means we have 3 non-white or 1 white and 2 non-white, and remember for the second case that we have an order. Now let's see the application. A box contains 6 white cards, 8 black cards, and 1 red card. So it has 15 cards, and we need to select successively with replacement 3 cards out of them. Try to find P of A alone. Now for P of A, it says that the selected cards should have the same color, so they could be 3 white cards or 3 black cards or 3 red cards. This is WWWBBB or RRR over the total, which is in this case 15 cubed, which is 27 over 125. Try to find P of B alone. The selected cards have 3 different colors. Now for this case, they could be W, B, R, and we never forget the order. W is 6, B is 8, and R is 1, and the order is 3 factorial. Try to find P of C alone. The selected cards have different colors. So the best way here is to use the probability of same plus the probability of difference is 1. And for the same color, it's the probability of A. And this would be 98 over 125. And finally, try to do P of D alone. Pay attention here to the selection. So the selected cards are white, then black, then red. So here the order is given by the question itself. So we have white, then black, then red. That's it. And the answer is 16 over 11, 25. Try to see the difference between P of D and P of B. For P of B, we have 3 different colors. They could be WBR, WRB, BWR, BRW, and so on. We have many possibilities. But for part D, the selection is very clear. We need a white, then a black, then a red ball. Now let's see the second application. U and V are 2 urns such that U contains 5 red, 8 black, and V contains 3 red, 10 black. So each urn contains 13 balls. 3 balls are selected randomly and simultaneously from U. and 2 balls are selected successively without replacement from V. So now we're going to choose 5 balls, 3 from U and 2 from V, and balls from U are selected simultaneously, whereas the balls from V are selected successively without replacement. Now consider the events. Let's begin with the probability of A. Try to do it alone, try to think about it. Remember, we have 2 different cases. Well, for P of A, it's better to represent it in this form as a couple. So 3 balls from U and 2 balls from V. We have simultaneous for the green and the successive without replacement for the blue. So in this case, we're going to deal with each case alone with a multiplication in between, because this means and. So we need to choose 3 red balls from U simultaneously. So 3 out of 5 over 3 out of 13 times 2 red balls from V successively without replacement. So we're going to choose 3 times 2 in the numerator and 13 times 12 in the denominator. And remember here that the order is not important because RR are the same letters. And this would be the answer. Try to think about P of B in the same manner. Well, for B, we have exactly 1 red ball is selected. It means we're going to choose only 1 red ball out of the 5 selected balls. So it could be 1 red and 2 non-red from U and 2 non-red from V, or it could be 3 non-red from U and 1 red and 1 non-red from V. Notice that in each of these 2 cases, we're going to have 1 red and 4 non-red. Now for the calculation, in the first case we have 1 red, 2 non-red simultaneously, so it will be a combination 1 out of 5 from U and 2 out of 8 over 3 out of 13. And then for the second case, which is a successive without replacement case, that's it. We're going to have 10 times 9, 10 non-red, 9 non-red over 13, 12, or means a plus. Again, 3 simultaneously from U, and here we have the order because we have different letters. Now try also to do P of C alone. Well, for P of C, the selected balls have different colors. The easiest, as we saw before, it's 1 minus the probability of the same color, which is P of A, means all are red, plus 3B, which is all are black. And this would be the final answer. Now let's see this application. Now we have 3 urns, U, V, and W. U contains 3 red, 6 black, V contains 4 red, 8 black, and W contains 5 red, 10 black. We need to select 2 balls simultaneously from U, 2 successively without replacement from V, and 2 successively with replacement from W. So in fact, we're going to choose 6 balls, 2 balls out of each urn, but the selection differs from one urn to another. Calculate the probability of selecting only 1 red ball from each of the urns U, V, and W. Try to do it alone. We need only 1 red ball from each urn. Well, in this case, this means RR bar, RR bar, RR bar. We're going to have an order in the second and third cases because these are successive drawings. Well, this is a combination 1 out of 3, 1 out of 6. For the second case, we have an arrangement which is 4 times 8 times 2 factorial, and for the third case, we have 5 times 10. And don't forget the order. Well, calculate the probability of selecting no red ball from U, 1 red ball from V, and 2 red balls from W. Try also to do it alone. No red ball from U means 2 non-red, which are black in this case. 1 red ball from V means 1 red, 1 non-red with the order. And 2 red balls from W means red, red. And we have to respect the specification of each case. This is a combination, this is an arrangement, and this is a power. This is what we get. In fact, this question summarizes all the different cases that we saw till now in probability. Let's see Rima, Amir, Mira, or Rami. An urn contains 6 red and 4 white balls. It contains 10 balls. 3 balls are selected randomly and successively without replacement from the urn. Calculate the probability of having exactly 1 red among the selected balls. So we need to choose 3 balls successively without replacement from the urn, and we need the probability of exactly 1 red. Let's see. Let's begin with Rima. Rima said that we need the probability of 1 red 2W. This is a combination and the answer is 310. Amir said that we need the probability of red WW because we need exactly 1 red. And this is 6 times 4 times 3 over 10, 9, 8, which is 110. Mira said that we need the probability of red WW, but we need to multiply by the order. So the same as Amir, but multiplying by 3 factorial over 2 factorial, and this is the answer. And finally, Rami said that we need the probability of RWW times the order, but he used 6, 4, 4, 10, 10, 10, which is 36 over 125. Now let's analyze these 4 cases. For Rima, Rima did it as if it were a simultaneous drawing, so this is not correct because she used the combination. For Amir, Amir forgot the order, and here the order is very important. Mira, I think, is correct. And for Rami, Rami did it as if it were a successive with replacement case because as you see here in the denominator, we have 10, 10, 10. He didn't decrease the total. So Mira's answer is the correct answer.